Hello, welcome to Electronics Education. This is Vincent Chang. In this lecture, we're going to continue our series on operational amplifier circuits, op-amp as voltage follower or buffer, op-amp as a voltage follower or buffer. Let's start with a non-inverting amplifier and try to convert a non-inverting amplifier to a voltage follower. So look at the left-hand side of the slide. It's the non-inverting amplifier, the closed loop gain G, which is defined as the VO over VI is equal to 1 plus the ratio of the two resistors, right? R2 over R1. If we let the R2 become an open circuit, or the value of the R1, if we let the R1 becomes the infinite, becomes the open circuit, the value of the R1 becomes the infinite. And the value of the R2 becomes 0, or R2 short circuit. If we open circuit R1 and short circuit R2, the gain will be equal to 1, right? And the gain of a voltage follower equals 1. What about a circuit? If the R1 becomes the open circuit, then you just cut it out. And R2 becomes what? Becomes the short circuit. So let the value of R2 reduce to 0. Then this is the circuit. The right-hand side of the slide is the circuit for a unit gain voltage follower. The circuit, this is a circuit, all right? The circuit of a voltage follower. So the closed loop gain G, which is defined as the VO over VI, will be equal to 1. Of course, if you apply the concept of virtual short circuit between the inverting input and the non-inverting input, the inverting input is connected to the VO, and non-inverting is connected to the VI. The voltage of the inverting equals the voltage of the non-inverting, right? So VO should be equal to VI. The ratio of the VO and the VI will be equal to 1. If you apply it to the concept of virtual short or virtual short circuit, so this is the outcome. VO equals VI. And then the second characteristic of this circuit is what about the input resistance of this follower? Is the same as the one in the non-inverting amplifier, right? The infinite. And the output resistance equals 0. So infinite input resistance and 0 output resistance. And again equals 1. So these three characteristics what kind of concept you remember of from these three important characteristics? The application of the ideal buffer. The concept of application of the ideal buffer. So this is actually a worst case scenario, right? You have the high resistance source and the low resistance low. You try to transmit the signal from a high internal resistance signal source to a low resistance low. If you do a direct transmission, remember, based on the voltage divider rule, then this is a relationship between VO and VS, right? The RL divided by RS plus RL. Then when RS is very high and RL is very low, which means the signal, there will be a signal loss during the transmission. A lot of signal strength is going to be eaten out by the source resistance on the left-hand side. VO will be much smaller than the VS. But if you insert a voltage buffer between A and B, instead of doing the direct transmission using a line, you insert a voltage follower between A and B. Then what happened? This is the takeaway. This is the key concept of a buffer. What happened? Because the input resistance of the buffer is infinite. And output resistance of the buffer is 0. What does that mean by the infinite input resistance of the buffer? Which means there's no current going through the RS. There's no voltage drop across RS. So VS will be direct transmit, will be copy, will be duplicate onto the non-inverting of the op-amp. And then the negative, because of the virtual short circuit between the two voltage terminal of the op-amp, the inverting terminal, the voltage of the inverting terminal will be copied, will be transmitted directly to the output. So based on the virtual short, the VO will be equal to VS. So in this, even in the high signal source, high resistance source, and the low resistance load, with buffer connected between the A and the B, there will be no signals loss at all. This is the key concept of the unit gain buffer. All right, this is the key takeaway of this lecture. Also, the key concept of a unit gain buffer. So this is the end of the lecture. Thanks for watching.